to Mathematical Minutes with Dr. Rhonda Fitzgerald, where we strive to give you understanding to mathematical concepts in minutes. So in this video, we want to discuss how to factor by using the X factor method, so the X method. So let's look at this example. So I want to attempt to factor the quadratic 3x squared plus 13x minus 10. And I want to factor this using the X method. So in using the X method, the very first thing that I want to do is draw an X. And at the top of my X, I'm going to use my A and my C term, because recall your quadratic is of the form ax squared plus bx plus c. All right, so I want to take the first term, coefficient, and the last term, right? My A and my C. So 3 times a negative 10, right? 3 times a negative 10, that gives me negative 30. And the middle, the bottom, is just this middle, my B term, my B term. My B term is a positive 13, so 13. So once again, the top of my X, right? The top of my X literally is just my positive 3 times my negative 10, right? My positive 3 times my negative 10 to give me negative 30. And then the bottom of the X is my B term, which is a positive 13. In order to complete this X, I need to come up with two numbers, right? Two numbers that multiply to give me a negative 30, but add to give me a positive 13. So once again, I need them to multiply to give me negative 30, but I want them to now add to give me a positive 13. And the two numbers that satisfies this is 15 and negative 2. So why is this the case now? Once again, because 15 times a negative 2 gives me negative 30, but 15 plus a negative 2 gives me 13. So now we know, yes, these are the numbers that we are looking for, 15 and negative 2. Okay, now in order to complete this process, what I want to do now is I need to look at the beginning of my problem, right? My leading coefficient was 3x squared, right? And so what I really want to do is just take the 3x, right? The 3x, and I'm going to put it over top here, 3x. So whatever this guy is what's going to go there, right? 3x. Now we just simply want to simplify these fractions. So I'm trying to simplify the fraction. I have 3x over 15. And when I simplify this, this becomes x over 5, x over 5. And so how does this translate to my factor? Well, nicely, I'm just going to shift this or slide this guy over. I'm just going to slide it over, all right? And this means that I have the factor x plus 5. And it's x plus 5 because my 5 is positive, right? So I just slide that over. So I have the factor x plus 5. Now let's look at my other guy here. Here we had 3x over a negative 2. So 3x over a negative 2. Notice that this guy is already simplified, right? I cannot simplify this fraction any further. So we're done pretty much. I'm just going to slide him over. And this implies that my factor becomes 3x minus 2 because that 2 is negative. So 3x minus 2. So this guy factors as x plus 5 and 3x minus 2. So let's look at a different example. Let's look at a second example in this case, right? Let's look at a second example. And my second example that we want to look at is 2x squared plus 7x plus 6. All right, so I want to factor that. And so recall that we start off by drawing our x. All right, drawing my x. And when I draw my x, now what goes in my x? So recall the outer numbers, right? My A and my C, they multiply to the top, right? They multiply to the top. So that becomes a positive 2 and a positive 6. All right, positive 2 and a positive 6. That gives me the number 12. And then the bottom becomes, we just drop this. I like the outside terms multiply together. The middle one just drops down. So my positive 7 drops down. So once again, I need numbers that are going to multiply to give me a positive 12, but add to give me a positive 7. So once again, they need to multiply to give me a positive 12, but add to give me a positive 7. And the numbers that we're looking for are 4 and 3. All right, 4 and 3. So once again, why is that right? Because 4 times 3 gives me 12, but 4 plus 3 gives me a 7. So we've completed our x. All right, we've completed our x properly. Now, how do we get our factors from this? So once again, recall what we did was we looked at the term there, right? The term there. So what I put that right here. So that becomes a 2x in this case, right? That becomes a 2x. All right, so whatever's right there goes on top. That becomes a 2x. So now my next step is to actually just simplify. And let's look. Actually, guys, this guy is simplified. 2x over 3. This cannot be simplified any further. So I already have so we have 2x over 3 can't be simplified. So remember, we're just going to shift him over. And this implies that my factor is simply 2x plus 3. All right, so we have the first factor of 2x plus 3. All right, so my next guy here, my next factor is 2x over 4. And how does this guy simplify? This guy simplifies as 1/2, or x over 2. X over 2. So now that we have this guy simplified, we just want to, once again, slide over. And this factor becomes x plus 2. So my last factor becomes x plus 2. And we always can check our factoring, right? If I were to multiply this back out, right, multiply whether you FOIL or whatever you use, distribute, but if I multiply this back out, I should get my starting problem, right? I should get my starting quadratic, right? So we could always check our factoring to see if we factor this right. However, this is factoring using the X method. And one other thing that I do want to mention when factoring using the X method, the first thing that I really should check, in which both cases that we've looked at are examples, that we've taken out a greatest common factor so that all three numbers don't have something in common. Because my first type of factoring I always check for is my greatest common factor. And that's really crucial when using the X method to factor, that there is no common factor. So we should take out our common factor first and then follow the steps for using the X method to solving a quadratic. So once again, this is solving a quadratic using the X method. Thank you.